Welcome to the arena. My name is Allyson Klein. This is a data insights episode, which means I'm here with Jeniece Wnorowski. Hey, Jeniece, how are you doing?
Hi, Allyson. I'm doing well. How are you?
I'm really fantastic. I know that we have a really cool topic today, and it's all about Solidigm for a change. So why don't you tell us what we're talking about and who you brought with you?
It's not always about Solidigm, that's right. But when it comes to AI and it comes to infrastructure and now software, I'm excited that I brought a fabulous guest. Today I have AJ Camber with me. Welcome to the program, AJ.
Hi, Jeniece. Thanks for having me.
Of course. And AJ is our resident VP GM of AI software at Solidigm. So we're excited to talk a little bit about a new technology that was just launched. Oh gosh, AJ, what, T-minus 3 weeks ago? A program called Lucetta. So we're going to deep dive in today and talk about how you can use this new technology and what a game changer it is. So thank you for joining us.
Yeah, thanks for having me.
To start off, could you provide a brief background on your role at Solidigm?
Yeah, thanks for asking that. So again, I currently lead the AI software group for Solidigm. So most recently at Solidigm, the last 2 years, I actually led our strategy team. And in our strategy office, we were focused on long-term growth. And this was actually one of the incubation projects that we had. And so in December, we decided to make it its own business unit based on the progress that we had made.
So AJ, from your vantage point, what's kind of changing in how most organizations are actually putting AI to work? What's your thought on that?
Yeah, from Solidigm, we are a leader in data storage, and specifically, we have some leadership QLC drives that kind of give us a different perspective, maybe than what you might have in the normal industry. And what we saw there is this kind of explosion of computer vision data, specifically. And so the data sizes, specifically related to cameras, are huge, right? Cameras can generate terabytes of video. And that's just like with a single inspection point. And so, specifically as we go into physical AI and other areas, we see this area of computer vision just really is the place for innovation right now.
I've been thinking that a core theme in your work is making AI significantly easier to consume. Why has accessibility become such a critical barrier in enterprise AI adoption?
Yeah, no, you hit on it, Allyson. Thanks for bringing that up. So with Lucetta, again, we're focused on kind of democratizing AI for everyone, and the reason why we do that is because of this scarcity of data science, right? So most of the tools out there, they're built for developers or even computer scientists that maybe aren't data scientists yet, and there aren't enough people that know how to use these tools to effectively use them, and it's just not easy to play with AI, and so. What we thought is that the engineers, working in the factory environments or working in the warehouse, these are the ones that understand the defects or the quality inspection items that you're looking for. And, this is like an underserved community, right? So even though data science jobs are growing, right? So, a few years ago, it was 250,000 in the world. I think the latest estimate for 26 was maybe 1 million. And the demand for those data scientists is over 11 million in 26. And to make matters worse, all of those data scientists, or the vast majority, are concentrated in like 20 companies. And so the probability that you're going to be able to have enough of this talent kind of in your company just as a manufacturer is probably difficult. So we thought that we needed to help out and do something, try to figure out a way to get more people involved.
I love that. And, on the surface, AJ, training models on your own data sounds, pretty straightforward. But as you and I have discussed and pointed out, there's a lot happening under the hood. So where do organizations usually, and typically underestimate the complexity of running these models?
Yeah, so good question. So all of these models, again, they use data, right? So generating the quality data sets, usually the first area of focus. That's another thing that our Lucetta product does. It helps you get to the point where you can collect data very quickly. Another nuance of this is that a lot of times, we hear a lot about pilots are easy to generate. It's quick to get some results that maybe work under common or perfect conditions, but we kind of all know that that's not really real life, right? So there's a lot of balance that you need in the data set. So you need a certain amount of diversification, right, to kind of compensate for all the complexities that kind of real life brings, right? But you don't always just want more data, right? So more data is not always better because it can cause like bias in the models or overfitting where you kind of unintentionally miss like outliers, for example. Or it could be like low quality or repetitive data that's not useful. And if you just generally add more data to models, which is conventional wisdom, right? The models actually get slower and more expensive to run, and it's bad for the environment. So, there's a lot of bad things. It's even more difficult to troubleshoot, actually. So the trick is just getting this just enough kind of mentality. And to do that, you have to be able to identify the right amount of data. And so most of the time when we think about Lucetta, what we're really doing is we're just trying to help people sort through massive amounts of data and find the most useful data so that they can generate these models the way they want.
You referenced the idea of AI generating AI. How is that shifting the way models are built, especially for teams that may not have deep machine learning expertise?
Yeah. So like I just said, there, the software basically automates a lot of steps for you. So, for example, Allyson, that's a good question. So, I just talked about data diversification. So maybe let's talk about that a little bit more. So we would estimate that if you did have a data scientist, that someone skilled in the art to do this would take maybe about 20 hours. If you're roughly making one model a month on a fairly large data set. And so, again, if you think about what you're paying in terms of a data scientist salary, 20 hours out of a month, that's roughly an eighth of a month, right? And so, if you're paying anywhere from $500 to $750 an hour, that's a lot of money, right? $10,000. So, with us, we automate that. So again, with our tool, we aim to kind of democratize and enable industrial engineers and mechanical engineers to do these sorts of things. And in that data diversification example I just mentioned, it's zero for us because we do that in the background for you. So that's one of the advantages.
So AJ, Solidym's Lucetta AI platform is really focused on enabling vision-based use cases, right? But what is it specifically about visual data computer vision that makes this area particularly impactful right now?
Yeah, I think the world's kind of headed to all of this robotics and really physical AI. And so all of that starts with cameras. And, for us, visual inspection is really just kind of one of the first, most obvious use cases, really in manufacturing, right? It's where we see it first. But there's a lot of other use cases too, right? There's like looking for personal protective equipment, like in safety and compliance application, or in warehouse environments, doing counting applications to do reconciliation to orders. But there's tons of quality inspection things too, like everything from textiles or weld quality to orange peel and paint. I mean, the applications are kind of endless. And so, from our point of view, one of the reasons why it's really interesting is because cameras, again, are just kind of more consistent than the people doing the job. They don't need to take breaks. They don't get tired. And so you have an opportunity really to take advantage of that by employing kind of these computer vision applications.
When you think about making these capabilities usable across different technical skills, what does a well-designed AI platform actually need to get right?
Yeah, that's a really good question. This to us, philosophically is something that we believe where we should allow people familiar with the domain to be transparently guided by a tool that can iterate and can iteratively improve the model output. So we don't think that our customers will be as successful as they can be if they're just using like pre-trained models, for example. So we want you to use your own data and to iterate on that tool so that not only is it tailored to your use case, but it builds trust with the people using it. And we see that that trust of the tools from the people working there is extremely important to adoption going. And so, again, that's a little bit of a philosophical difference, and it has to do with the way we've put together kind of our AI pipeline in order to converge models very quickly on a very small amount of data.
Yeah, AJ, there's always a trade-off, between simplifying the experience and kind of maintaining transparency overall. But how do you think about balancing abstraction with the need for control and trust?
Yeah, so we think that the best approach actually is one that assists the people working kind of on the line. Again, we're not trying to replace anybody, right? So it turns out the models actually work better when they get the benefit of the judgment from the people, their human counterpart, or if you will, and by allowing the person to see in a systematic way, this kind of collaborative improvement towards KPIs, we actually, get better results than you might have otherwise gotten if you tried it with maybe a different approach a few years ago.
For organizations applying AI to real-world operational environments, what separates projects that scale successfully from those that never move beyond pilots?
Yeah, I think in this case, I would say that it comes back really to that quality and variation in the data set. So, like I was saying earlier, there's a lot of complexity in the real world, and one of the implications of that is that the model that's perfect today is really not perfect tomorrow, and so we should be really encouraging teams to iterate with their own data, make sure that they have enough of that variation to be successful, because perfect conditions are not going to get you the results you want. And this flexibility too is a little different, right? So traditional optical inspections are very rigid, the kind that aren't really AI based. But one of the benefits of using an AI based approach here is that you achieve this flexibility, which enables the model to adapt, right? And so, again, like, not all scratches are identical, and not every dent's going to be in the same part. And by using AI training techniques that allow for this adaptation, I think, again, you'll be more successful than if you weren't doing that.
So as tools kind of make it easier to build and deploy models, how does that change the role of domain experts versus, say, traditional, science teams?
Yeah, I think it just means that, if you have a tool like Lucetta, you are less dependent on just a few individuals, like I was mentioning earlier, which means you should be able to get more done, right? But by the way, it's great to have a data scientist be part of the team and leverage their expertise on where to go forward. But if you have a tool that can automate some of the more rudimentary aspects of the job, then you can get, their efficiency can be better too. So, I think our goal is to improve the efficiency by raising the level of contribution from everyone.
Now, looking ahead, how do you see enterprise AI software evolving as expectations shift toward faster deployment, broader accessibility, and even more measurable outcomes?
Yeah, we're still at the beginning of this, but I would say that I could simplify it down to just a few things. I mean, for our customers, our application expectations are pretty straightforward. They're just looking to save time, and it's easy to dollarize what that time's worth, whether it's a data scientist or mechanical engineer, or people annotating specific amounts of data, or in the quality inspection space. What they're looking for is to actually improve their yields, right? So just throw away less product, make sure that quality defects are caught before they, as early as possible before they leave the factory, which is also easy to dollarize. So again, our customers definitely are looking for ROI, and I think most cases boil down to kind of those two items, or at least that's what we've seen so far.
Okay, so you've seen that so far, but show us, right? We would love to see a demo, and I know you have a cool demo, but it would be fabulous for us to kind of can we see this? Can you show us? Can you walk us through what this kind of actually looks like? We've never done this on a segment before where we've had kind of a show and tell. So I'll turn it over to you, AJ. Just kind of show us the visualization and talk us through a demo.
All right, so what I'm showing you is the Lucetta dashboard here. And what I want to show you is how easy it is to kind of get started. So the first example I'm going to show you is like a simple packaging content case. So think about like a big box store where you have maybe some furniture that needs put together. And what we're going to do first is set up our first camera as a packaging station. So we're going to add just a regular RSTP stream to the configuration, and we'll go back to the inspection area to look at the live viewer, and you can see we now see the stream. It's looking at a couple of nuts and bolts there. I just marked a bookmark. So we clicked on a bookmark there. The reason why we did that is because we want to annotate a few images, try to teach the model what we're looking for. So here you see we've highlighted a bolt and there's a nut. So now we've annotated that image. And while we've done that, the software has actually propagated those annotations to more images. Now we're ready to make a model. So we're going to give you an object detection profile. We're going to click the two annotations we just did. We'll give it a new name so that we can create a model right here. And then we're going to focus on whether or not we want to minimize false positives or false negatives. In this case, we're going to focus on false positives. You can see we just kicked off the model creation. So it was that quickly that we were able to do that. Let's go back to the live viewer again. You can see the camera still looking at what we thought originally. But there was no model running. So now why don't we add our model to the visual feed there. And so let's add the model we just created, update the configuration, and go back. And now you can see, it's labeled the nut with certain probability and the bolt. But let's add a few more. Here's another bolt. Let's add another. Okay, that's a nut. It seems to be working. Let's add another item. Oh, that's not a nut or a bolt. Seems like it's working. So again, just a really quick demo to show you how quickly you can not only annotate a few images, but also get to a working model in a pretty straightforward way.
This episode was fantastic. I know that people are going to be interested in talking to you more. So for listeners who want to learn about Solidigm's AI software and the work you're doing, where should they go to engage your team?
Yeah, so the easiest way is probably just to reach out to me or send us an email. So email address is industrialaisw@solidigm.com. Or you can also follow the link, I think, that we just dropped in the chat here, solidigm.com.